Today we're doing lesson 3.8, addition of fractions. So we've gone over the math warm-up on page 39. Now we're on page 40. It says sum of jumps. What does sum tell you to do? Mary? Add. Sum is the answer to an addition problem. Mary, put yourself down for a point. Speaking of the answer to different operations, so there's 4 operations in math. Only 4. Everything that you do in math is based on 4 operations that you already know. Addition, when you add 2 numbers together, it equals a sum. Does anybody know what the answer to a multiplication problem is called? It begins with a P. Todd? Avis? Yes, it's a product. Okay. Anybody know what the answer to a division problem is? Fisher? Begins with a Q. What'd you say? A made-up word. Devin? No. Evan? Audrey? Keep your hand out of the... Yes. Quotient. Quotient. You guys are all just making up or guessing keywords. Okay. The answer to a subtraction problem begins with a D. Evan?
The hydrant.
Colton?
Distract.
Jackson, do you have a true math word? Okay. It's difference. I just told you what it was. The answer to a subtraction problem is called the difference. Okay? So, I want to direct your attention over here to this word clues. Addition. The answer to an addition problem is called a sum. The answer to a subtraction problem is called difference. The answer to a division problem is called quotient. The answer to a multiplication problem is called product. Okay? I tried to turn that air off and it made a weird noise that it does when it's messing up, so I'm just going to leave it. It'll kick off soon. Okay, on each number line, draw 2 jumps to show how to use 6 to make a sum of 8 6. Then write an equation to represent each combination of jumps. So they gave us a point right here, which is 8 6, because watch, 1 6 2 6 3 6 4 6 5 6 6 6, or 1 whole, 7 6 8 6. So 8 6 is what we're going to write underneath that point. Do that now. Eight. 6. Now they want us to start at 0 and make 2 jumps. So we're going to start at 0. Let's make our first jump right here. So boom. Boom. Kind of a messy one. Let me fix that a little bit. Okay. So when we started at 0, how many 6 did we go to the first point? We went 1 6, 2636. So that's the first number in our addition problem. 36 plus, write this down. Then from here we went 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So 3, 6 plus 5, 6 equals 8, 6. Why are you not writing? Okay, so what do you notice about this equation that we just wrote? Jackson, what do you notice? Tell me about the denominators first. What do you notice about the denominators? They stay the same, yes. So the denominators are the size of the pieces. They don't change just because we're doing jumps, right? The pieces are, or the number line is split up and they don't change size. So the denominators stay the same. What do you notice about the numerators, Athena?
If you add 3 plus 5, it equals 8.
Exactly right. 3 plus 5 equals 8. This is something I want you to remember, that when you're adding fractions, give me your attention. When you're adding fractions, the numerators get added, but the denominators don't. We're going to have a conversation. Okay, next we're going to jump to 8 6 again, but we're going to do it in a different way. So I'm going to start at 0 and I'm going to go to right here. So I'm going to go to the mark before one whole and then jump the rest of the way. So how far did we jump to begin with? 1 6 2 6 3 6 4 6 5 6. And then we jumped 3 more 6 for a total of 8 6. All right, Noah draws the following diagram and writes this. 8 6 equals 6 6 plus 2 6. And 8 6 equals 1 whole plus 2 6. Which equation is correct? So this is what he writes. 8 6 equals 6 6 plus 2 6. And he also writes 8 6 equals 1 whole plus 2 6. Talk that over with your neighbor and discuss which one you think is correct.
Stay close. I think the top one is that
All right. I heard some good conversations, but here's my question. Isn't this the same thing as this?
Yes.
So they're both right. They're both correct because this is 6 6. This is 1 whole, but it's the same thing, right?
6 6 are both.
So they are both correct. So here's what we're going to write. Both are correct. Both equations are correct. Both equations are correct. Geralda, you need to start writing. Because 6 6 equals 1 whole. So you can see they start at 0 and go to 1 whole, and then he goes 1, 6, 2, 6. So that's like 1 whole plus 2, 6. But 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. 1 whole is the same as 6, 6. So that represents both equations would work. Because 6, 6 and 1 whole are the same thing. We're going to start talking about some mixed numbers today, which are a combination of a whole number and a fraction. So like if you had the mixed number 3 and 1/5, you would say 3 and 1/5, okay? So that's like you ate 3 whole candy bars and 1/5 of another one, okay? On each number line, draw jumps to show how to use thirds to make a sum of 7 thirds. Then write an equation to represent each combination of jumps. So we don't have to just do 2 jumps. On this one, it doesn't say just 2. So we can do more than 2 if we want, or we can just do 2. The minimum amount is 2 though, because we have to have an addition sign in there somewhere, okay? Because we're adding and getting a sum of 7 thirds. So, to start with, if I look from 0 to 1 whole, there are 1, 2, 3 sections, meaning that all of these parts are cut into thirds. Colton, stay focused up here, please. So, I'm going to start at 0 and jump to 1 whole, and then I'm going to jump again to 7 thirds. So this one, the equation would be 3 thirds. That's how far I jumped first. Why are you not writing? Plus 1/3, 2 thirds, 3 thirds, 4 thirds. 3 thirds plus 4 thirds equals 7 thirds. Denominators have stayed the same. Numerators add together to equal 7. Okay. Next we're gonna jump here, and then here, and then to the black dot. So we're gonna go 1, 2, 3 jumps. Since we have 3 jumps, whose is this? Is that yours? Since we have 3 jumps, we're gonna have to go, this is 1/3, 2 thirds, so that's where we start. 2 thirds plus 1/3, 2 thirds, 2 thirds plus 1/3, 2 thirds, 3 thirds. And if you add up 2 plus 2, what do you get?
4.
And 4 plus 3?
7.
7. And the denominator stays the same. Next it says write 7 thirds as the sum of a whole number and a fraction. So there's 2 different options. I'm gonna draw one out here. So if I have 0, 1/3, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7 thirds. So I'm going to right here, 7 thirds. And they want us to write a whole number plus a fraction to get 7 thirds. Avis, what whole number plus a fraction could we write?
2 plus 1/3.
Yes, nice job, Avis. 2 wholes plus 1/3. Because 1 whole would be right here, 1/3, 2/3, 3/3. 1/3, 2/3, 3/3. So this would be 2 wholes, right? Or 6/3. 3/3 is the same as 1 whole. Sit up, Audrey. 6/3 is the same as 2 wholes. Because what's 6 divided by 3?
2.
2. Okay? So what's 3 divided by 3?
0.
1. Okay, so if we're at 2 wholes and then we jump another third, that would be 2 wholes plus 1/3 equals 7/3. Is there another way to write 7/3 as the sum of a whole number plus a fraction? Jackson?
1 plus 2/3.
Is 1 plus 2/3 7/3. So this would be 3/3, 4/3, 5/3. Would it be 2/3?
1/3.
Nope. Todd? 1 whole is 3/3. How do we get from 3/3 to 7/3?
You go by
Jackson?
4/3.
It would be 4/3 because 1 whole is 3/3, right? And we need to get right here. So we would jump 1/3, 2/3, 3/3, 4/3. Does that make sense? Okay. So because 1 whole we could replace with 3/3. Zerelda, are you paying attention? Give me what you're missing. Okay. You're not focused at all. Okay, so here's what I want you to write down. 2 plus 1/3 equals 7/3. And then I want you to write 1 plus 4/3 equals 7/3. I'll get you another one.
Wouldn't 4 minus
Sum. Sum. Sum tells you we're just doing addition. So, it has to be an addition problem. There, we will get into jumping backwards tomorrow.
Yes.
All right, start writing. What is the sum? Use a number line to represent each addition expression and to find its value. Okay, so what size are all of these parts? Cameron, what size are they? Count with me. 1 whole, there's 8. So that means 1 whole is 8 eighths. And so what denominator are we going to use for this equation? 8. Okay. So they're wanting us to put this on the number line. So our first jump goes, Todd, sit up, pay attention please. 1/8, 2/8, 3/8, 4/8, 5/8. So everybody write that down. Write the dot. And then from there we have to go 1/8, 2/8. So we're going to put another dot right here. And we're going to jump from 0 to the first dot. There we go. And from the first dot to the second dot. And where do we land on the second dot? Zerelda?
7/8.
Yes, ma'am. Good work. 7/8. And that's also what this equation. Look at the numerators. What's 5 plus 2? 7. So 7/8 is where we land because 5/8 plus 2/8 is 7/8. Okay? On the next one, it wants us to add 1/8 plus 9/8. So our first one is going to be at the 1/8. And then we're going to count up 9 from there. So we're going to go, so this is our first 8th. Then we're going to go 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8. So it's going to be 2 marks after the 1 whole. So we're going to jump from 0 to 1/8. And then from 1/8, we're going to jump 9/8. Where does that land us? Fisher?
10/8.
Yes, 10/8. Okay, on the next one, our first jump is going to get us where, Colton? Where's our first jump get us to?
9/8.
Where's our first jump get us? Mary? To 11/8, right? Because the first number is 11/8. So we're going to go 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8. So it's the third mark after 1 whole. That's going to be 11/8. And then from there, we're going to count up 9 more. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the 5th one from the back. So I'm going to double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So we're going to jump from 0 to our first jump and our first to our second. And what does that equal? Ari? 28. Because 11 plus 9 equals 20. And the denominators stay the same. On the next one, we have to find where 2 and 1/8 is going to be, and we only know where 1 whole is. And we know that's at 8/8. So where would 2 wholes be? Avis?
16/8.
16/8. That's correct. So if this is 8/8, we're going to go 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, 16/8. So this is where 2 holes would be. And then, but that's not what they want us to focus on there. They want us to do 2 and 1/8. So that's going to be 2 holes and 1 more 8. So now you need to put the 2 at 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is 2 holes. But this is 2 holes and 1 more 8. That's our first jump. And then we need to count up 4 more. So 1, 2, 3, 4. So our first jump gets us to 2 holes and 1/8. And our second jump gets us 4 more 8s. So where would that get us? 2 holes and 1/8 plus 4 more 8s. Fisher?
2 wholes, 5/8.
Yep, 2 5/8. Very good. Because I like to stack fractions like this, and then you do the fraction adding first. 1/8 plus 4/8 gives you 5/8, and then the 2 wholes just comes down. Okay, so right here is 2 wholes and 5/8. Okay, so this next one is pretty cool. I'm gonna switch over to my document camera because we've got 3 kids and they are adding 1 2/5 plus 4/5. So here we go. We've got Priya, who says that 1 2/5 plus 4/5 equals 1 6/5. Then we have Kieran, who says that 1 whole and 2/5 plus 4/5 equals 11/5. And then we have Tyler that says 1 whole and 2/5, and 2/5 plus 4/5 equals 2 wholes and 1/5. Okay. Guess what?
What?
I'm going to show you with the document camera. Okay, here we go. We're going to see who's right. Priya, Kieran, or Tyler. Who do you think is right?
Kira. Tyler. Kira.
Who do you think? Avis? Tyler? Who do you think, Audrey?
Priya.
Priya? Who do you think, Jackson?
Tyler.
Tyler? Okay, let's do this. Raise your hand if you think Priya is right. Keep it up, keep it up. Let me count. 1 2 3 4 5 6 7 8. Okay. Raise your hand if you think Kieran's right. Nobody? I thought somebody said it. So really, you just feel bad for Kieran, right? Because nobody voted for him. What about Tyler? 1 2 3 4 5 6 7 8 9. Okay. Let's see. Let's just see. So this is what we're adding. We're adding 1 whole and 2/5, which is right here, plus 4/5. Okay? So if I put those all together, I have 1 whole and 1/5, 2/5, 3/5, 4/5, 5/5, 6/5. So Priya's right. But what if I exchange my 1 whole? How many fifths will I exchange it for? Shout it out.
5/5.
5/5. 1, 2, 3, 4, 5. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So Kieran's right. But what if I exchange 5 of those fifths for 1 whole and another 5 of those fifths for another whole? Guess what? Tyler's right too. They're all right. Because 1 6/5 is the same as 11/5 is the same as 2 wholes and 1/5. So all are right. Pretty cool, right?
Yeah.
It's just different names. It's just different names for the same quantity. Okay?
It's 2 wholes and 1/5.
So okay, here we go. So if we, so all of them, write this down,
Oh, we don't see
are
it.
correct.
See it. We can't see it.
Oh, sorry. I forgot to switch it back. All of them are correct.
By the way,
At the very bottom of the page. All of them are correct because 1 6/5 is equal to 11/5 is equal to 2 wholes and 1/5. They are all equivalent. Just like 1/2 is the same as 2/4 and 2/4 is the same as 4/8. It's just different ways to represent the same thing. Okay. And we can look at a number line real quick and I'll show you why. So the first one was 1 2/5. That would be right here. And 4 more fifths would be right here. So if we jumped from 0 to 1 2/5 and then jumped 4 more fifths, that would land us at 1 6/5. Or if we were just counting by fifth size parts, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5. Or if we plug in the second whole number, every 5 is 1 whole. So 1, 2, 3, 4, 5. This would be 2 wholes right here. So 2 wholes. So 2 and 1/5. So they're all equivalent. Okay, so we've got one more page to do, and this one you're going to have 4 number lines, and what I'm going to do is, do you see how on page 42, there's 4 number lines, and they all have a dot on them. Do you see that? How all the number lines have a dot on them.
yeah.
So we have to find out what that dot is, and our first jump I'm going to give to you. So your first jump is going to be, oh, by the way, let's see what our denominator is going to be. So Evan, if we start at 0, look how many sections are between 0 and 1 whole. 1, 2, 3. So what's our denominator going to be on all of these problems?
3.
Evan?
3.
3. Okay? So I'm going to write 3/3 right here, 3/3 right here, and 3/3 right here, and 3/3 right here, just to have like another starting point for counting. Okay, now, on number 1, I want you to start your first jump at 4/3, and then write an equation. So what I mean is you're going to start at 0 and go to 4/3, and then from 4/3 to this jump. And then you're going to write an equation. 4/3 plus, count with me, 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. 4/3 plus 6/3 equals what? Todd? 10 what?
10/3.
Yep, 10/3, that's right. So that means that this dot, I'm I'm gonna write 10/3. That's our stopping point. Okay? So that's what you guys are gonna do. I'm gonna give you, hold on one second. I'm gonna give you the other fractions that I want you to start with. One second, because I want you guys all have the same one. So, we're gonna do, let's do for, we're gonna do start, our first jump is 7/3. Our first jump on this one is 9/3. And our first jump on the last one is 2/3. Okay? So, let me stop this video.